Welcome to a lesson with Dr. Powell. Let's take a look at another example of L'Hopital's rule, where the top is heading toward infinity and the bottom is heading toward infinity. Consider the limit as x approaches infinity of 3x squared plus 2x minus 1 over 5x squared minus 2x plus 7. All right, so let's take a limit of this. Now, notice that the top does head toward infinity and the bottom does head toward infinity as x goes off. So this is okay. We can do this. All right, so we can take a limit of the top and we divide it by the limit of the bottom and replace the limit. Now, when we do this, we get 6x over 10x. Okay, and then the derivative, we have a plus 2. And then we have a minus 2. Okay. Notice that again we have to infinity, so we have to apply this rule again because we can't just say what infinity over infinity is. We have to keep going. So we take L'Hopital's rule again. We take the derivative of the top, which is 6 divided by the derivative of the bottom, which is 10. And notice, hey, that's well defined. I mean, in fact, that's just 3/5 if you simplify. Now, let's actually take a look at what's happening here. When we use L'Hopital's rule, notice how the leading term here is has the same degree as the leading term here in the denominator. Now, also notice that, okay, so that means it's going to take the same number of derivatives to make these guys get down to be constants. Now, in the process, guess what's going to fall away? This is going to disappear. And so its contribution to the limit is going to not even occur because it's going to be gone. In this step, it was gone. Now, these guys also eventually will fade away. At least their derivatives will fade away before we get to these at the end, which means that the limit itself does not even depend on the lower degree terms at all by L'Hopital's rule. We can even take that as a lemma or a sub-theorem. If you have a polynomial over a polynomial, L'Hopital's rule guarantees that eventually these guys will fade off in repeated applications of L'Hopital's rule before these guys do. That's meaning that the whole limit depends on just the leading terms themselves. And everything else can be ignored in taking that limit. So notice if we just had written down the limit as x approaches infinity of 3x squared over 5x squared, then algebraically we could have seen very quickly that the limit was 3/5. Now, this is true for degrees that are leading terms that are the same here, have the same degree. But also, what about if we have something like this? The limit as x approaches infinity of 2x plus 1 over x squared minus 3. Now, again, we can actually do the same idea. If we just tack on a 0x squared here, notice that those will vanish and those will vanish, and we'll just be stuck with these leading terms here. Well, so the limit will be 0 over 1, or in other words, it'll be 0. So if the leading term on the top actually has smaller degree, we can be sure that the limit will be 0. Likewise, what if we had flipped this around, x squared minus 3 over 2x plus 1? We could have done the same trick and done as like a 0x squared here. And then thought in the end it's going to be like this, which looks undefined, 1 over 0. However, if we keep in mind that as x goes off to infinity, as x goes off to infinity, these guys are going to be positive, and these guys up here are going to be positive. So we're really looking at positive infinity is what we're going to be looking at, 1 over a very small number, at least in the ratio. So the limit would be this. So this is kind of just a brief description that you can say by use of L'Hopital's rule, but then still quickly get what the limit is without actually going through all the repeated applications of L'Hopital's rule by just looking ahead at kind of what's occurring with L'Hopital's rule and what seems to vanish first, and what remains and what the limit actually depends on. Now, what does this work for? This discussion was only for polynomial divided by polynomial. Polynomial when x itself is heading off to positive or negative infinity. Now, in this particular case, this is when we can use this L'Hopital shortcut, if you will. Thanks for watching.